Hello and welcome back. Before we dive into building our command line tool with Python, I want to make sure everyone is on the same page when it comes to the language itself. If you're not familiar with Python, especially with things like classes or some of the more advanced concepts, I highly recommend you check out this official Python tutorial. You can find it at docs.python.org/3/tutorial. So in this page, you would see different chapters that covers different aspects of Python, all the way to modules, input and output, error and exception, classes, brief tour of the standard library, and the likes. Go through it at your own pace or just keep it open as a reference while you are taking this course. We'll be touching on several Python concepts as we build, so having this handy would definitely help. Now, if you are completely new to programming, no worries. I've got you covered with a separate course called Introduction to Programming. You can check that out. That course is designed to give you the foundations you need before jumping into this one. So you don't have to proceed with this one. Just go back to that one, get grounded before you return. On the other hand, if you're already familiar with Python, feel free to skim through the tutorial just to refresh your memory or revisit any topics you are a little rusty on. Okay, with that, let's get started. Before jumping into the code, let's clarify something. What exactly is a CLI? CLI stands for Command Line Interface. It's a way for users to interact with your application by typing commands into a terminal. Rather than clicking buttons in a graphical interface, in our app, users will run commands like Python main add -product like this, main.py add -products. As we've seen before, here we just put your name. A simple product would be, for example, water. The SKU would be something like BT1L. Purchase price 12.669. And product butter added with SKU BT1L. Now, each of these commands will trigger a function in our Python code. And that's what makes it a CLI tool. We'll use a library called typer. And so we are going to use a library called typer to build this interface. And think of typer as a smarter, simple way to handle CLI commands, but on top of the popular click library. Right. So we're going to initialize our project. I have taken some time to create the initial Git repository, and I also created a sub-branch called part 1, as you can see here. So let us see what the structure of our project is going to look like. And you can always reference this Git repository. I will place the link in the notes section of this course for you to have access to the Git repository. So let's see what the structure of our project is. The root of the directory is a trademark here. We're going to have a main top folder called the app. Let's make an app directory, and in this app directory, we're going to create a CLI.py file, and then we're also going to create models.py file. For the CLI.py file, the CLI commands go here. Let's see if I call it up here. CLI commands go here, right? And then for the models.py, we're going to have our SQLAlchemy models, and then we're also going to create the db.py in the core application code folder. Let's call this db.py for our database. And I'm going to put a comment here that says database connection and setup here. Connection and setup here. Right. And then the next folder we want to create is the tests directory. So let's make directory tests. And this is going to be for our files, our automated test files. And of course, we need to have our entry point for the CLI, which is the main.py. That's going to be in the root folder. And then we're going to need the requirement.txt to store our Python packages that this project is going to require. Now, this modular structure keeps things clean and maintainable. Everything related to logic lives inside the app directory, while the test ensures our code is reliable. Now, let's quickly create a Python environment for this project. So to do that, we want to use pyenv virtual env. I'm using pyenv virtual env, so I'm just going to create my virtual env using the command pyenv virtual env 3.10.12, and I want to call the virtual env trade track. That's going to create a virtual env called trade track for me. And then the next thing I want to do is to activate it. Pyenv activates trade track. And there we have it. And then I want to install typer, pip install and I also want to install SQLAlchemy. Right, that's good. Let us set up the typer CLI in the main.py file. Here I have the first line that says from app.cli import app, and this imports the CLI command defined in CLI.py. Right now, we don't have anything there. We're going to build that soon. And then the next line here says if name equals to main, line 4 says execute app. Now, why is this important? If name equals to main is a common pattern in Python that is used to control what code runs when a script is executed directly versus when it is imported as a module in another script. So this line 3, checks if the script is being run directly and not imported. As for line 4 tells typer to start the CLI when the script run. This is a Python pattern. And this Python pattern is used for two things in general. The first one is for reusability, and then the second one is for entry points. In terms of reusability, if this script, for example, were to be imported into another file, it's not going to execute unless you specifically tell the file which function you want to execute from these scripts, assuming there is a function defined there like def greet me. If I were to import this main.py into a different file and execute it, nothing is going to happen unless I tell it execute greet me directly. Otherwise, if I am running this script directly, then it's going to execute app, because it's saying if this script is run and being executed directly, then run this function below. Of course, I'm importing it here to run it as a main function. So that's what this does. Now, this is all we need to launch our CLI tool. The next thing we want to look at now is the database. For the database, let's do this. I'm going to paste the snippet here, and I'm just going to explain. It's easier to explain than to type all of this from scratch. So at the top of our models.py, we import everything we need from SQLAlchemy. Now, these are the building blocks of our database models: the column, integer, string, floats, foreign key, datetime, enum, and the likes. Now, declarative base is used to create a base class for our models to inherit from. It has a couple of attributes like metadata. So let me show you real quick what that looks like here. When you go to SQLAlchemy, so let's say SQLAlchemy declarative base. This is what declarative base is and what it is used for. When you use declarative base, you use it as a base to create your models. Okay, so remember I asked us to reference this documentation. So if you've not referenced this documentation, you can have it open, just have it open, make reference to it as we build, in case you are not sure of certain things we are using. But I'm going to try my best to explain it as much as possible so that we are not lost. We have a clear understanding of what we are building. Okay, and then the enum and datetime here are standard Python modules to help us define our transaction types and timestamps. The next thing we want to look at is to define a class called transaction types that inherits from enum.enum. Now, we define two types here, two types of transaction: purchase and sale. And this will help us keep track of what kind of transaction each entry represents. And after that, we want to look at another class here. We want to define our model. The first model we're going to define is the product model. So the model class called products. Now this class defines what a product looks like in our database. And if you are not familiar with relational database, that's okay. I have in the notes section a primer called database primer. So I have a primer in the notes section. Take a look at it, read it slowly. Don't be in a hurry. Make sure you understand it before you continue if you're not so familiar with the concept of relational database. Now, this class called product defines what a product looks like in our database. And here we have the table name. Table name tells SQLAlchemy the name of this table, that's product. And then each column here, like ID, name, SKU, category, purchase price, defines a field in the table or the attributes of our product. So we're saying our attributes should have a name, it should have a category, it should have a purchase price and a SKU. And then one more field here, transactions. The transaction links this model, that's the product model, to the transaction model, which we're going to define in a bit. And this is how we create relationships in SQLAlchemy. Then let's consider the transaction model. For the transaction model, we have fields as well, similar to that of the product. And we say the transaction should have the product ID, the type of transaction, which is calling enum. Enum here is referencing the SQLAlchemy enum, which is different from the enum.enum, which we've defined here. So take note, this one is coming from SQLAlchemy, while this one is a typical Python standard enum. And this is for us to determine, what type of transaction, if it's a purchase or sale. And the reason why it's set like this is so that we only have two types of transaction, either a purchase or a sale, nothing more, nothing less. And then we have our foreign key here, which references product.id, and this links us back to the products model here. And then we have the default datetime.utc now. This is for the timestamp. This is to timestamp our transaction. And of course, products. This again links back to the product table. Right. And then that's it about models.py. The next thing we want to look at is the db.py. Database connection and setup happens here. Yes, it does. Okay, so let's see. Right here, I have here the code for our db.py. That is for our configuration. And I'm going to explain what's going on here. Now, this file connects our Python code to our SQLite database. Now, here we have the database URL. Of course, we're importing two main things from SQLAlchemy. We are importing create engine and session maker. And then from app.models, we're importing base. That is, we're importing base from app.model. Oh, I forgot to, so base here is equal to declarative base. I forgot to set that properly. Right. So DB just says from app.model import base, which we declared here. So declarative base is instantiated here, and then it's used as a base class for our products model and our transaction model. The db.py, on the other hand, has the database URL, which is a string that tells us two things here. One, we are using an SQLite database, and this is the location of the file. We're going to put the file we're going to put the file in the main directory here. So the file is going to be in the root directory at the same level as main.py. So we say step out dot / track.db just say step out of the app directory and put the db in the roots directory. So it tells us the location of the db file, which is local to our directory, and the type of database we are using, which is SQLite. The next thing is create engine. Yeah, create engine is how SQLAlchemy connects to the database. So it takes in the database URL and then the connection asks. Create engine is how SQLAlchemy connects to the database. A very simple way of putting it is like this. If you are in location A and you want to talk to your friend in location B, you would use your phone to dial your friend's number. So think of your phone dialing your friend's number as the create engine that establishes the connection. So when you dial your friend's number, you establish a connection with your friend. That's what the create engine does. So create engine literally connects to the database. And then session looker over here is what gives us a way to interact with the DB. So it's kind of like opening a document for editing. I think I can explain it like this. Session maker in itself doesn't create sessions. It's a factory. So in Python, there is something called factory pattern. So let's see what that is real quick. So in Python, there is something called factory pattern. The factory method patterns offer several benefits. I'm looking for So let me just explain it. In Python, I have a function, and this function or object knows how to create other objects for me. And that function in itself uses a factory pattern. So if I create a function, and this function I have created, I want to use the function to create another function. That technique or that pattern is what we call the factory pattern. So in SQLAlchemy has by default sessions. Sessions is how you talk to your database in SQLAlchemy. But if you are to use a session, you will need to always create a session in order to communicate with your database and do things like committing, flushing, rollbacks. And you do not want to always create sessions every time. And that's why you use a session maker. So this is the document. Let's see what the document says real quick. So let's go to home and let's just go find that. I would say document overview for a start. No. Installation guide. Yeah. Let's go to the tutorial. See. Let's see what it says here. I'm going to right. I think this is where I am. So you have sessions. Now, sessions establish all conversation with the database and represents a holding zone for all the objects which you have loaded or associated with it during its lifespan. Now, this is how you use a session. You import create engine, you import session. So here you connect to your database, like we saw earlier, tell it the type of database, put in the DB API you want to use. For Postgres, you use Scikit-2. In our case, we're just using SQLite, so we're not using, it would use a default DB API. You can reference the docs for that, and this is the location where the address of the database, right? How to username, password, and at database, localhost. And so now that you've imported your session, you need a way to talk to the database, have conversations with the database, and that's where you create your session. Now, if you do not want to do this every time you need to interact with database, what you need is a factory, or should I say a session maker. And what the session maker does is that the session maker is callable. Session maker produces a session instance. So let me see if I can find a session maker here. I will still find that here too. Give me a moment. Let me drop down to it. So yeah. So the purpose of a session maker is to provide a factory for session objects with fixed configurations. So take note of this, fixed configurations. So you create your engine, an engine which the session will use for connection, resources, and typically in module scope. So we create our engine, and then we use a session maker within the scope. So the session maker is not a session in itself. The session maker returns a factory. And the reason why they call it factory is because session maker is callable. Session maker does not return a session, but rather it returns a factory. It returns a factory. And it's a factory because it is callable. And that means that it produces a session instance when you call it. To call it, you have to use the open and close bracket. That's how you call it. So with session, this is when you call it. You call the session using the open and close bracket, and that returns a session like this. And it is with this session you add and you commit. So instead of always instantiating the engine, creating the engine, and then using the engine to create a session every time you need to interact with the database, you instead use a session maker. And the session maker will only be called. The session maker will only create a session when it is called, and this is how you call it. So that's what it does. Yes, that's simply what it does. The session maker is a factory. because it is callable. And when you call it, it returns a session. So if all of this is too much, I would say come back here, take a good look at this documentation. It's going to make sense to you if you look at it a second time. So when do I make a session maker? So read about it, take your time, and you'll see the use of it. Okay. So with that said, our create engine is how SQLAlchemy connects to the database. And then we have our session looker here, which is a session factory. And what will happen is that when we start creating our CLI.py functions, we're going to come across session looker, which is where we're going to call session looker, and session lookers will create a session for us. And then the initDB here creates the database table based on our models, and it runs it just once. So we have base we've imported from models. Then we say base.metadata.create all bind engine. And what this does is that it creates the tables based on our model once. So the tables are the ones we created in the models.py. The metadata object accesses the table objects for us, or should I say table fields or table attributes. It accesses that and uses that information to create the tables here. And this is done just once. And this is why we say the db.py file is used for database connection and setup. So this is kind of like where we make the configurations for the database. And that's it. In this video, we've completely set up the structure for our CLI app. We've also learned how to define SQLAlchemy models to represent real-world data. And then we've created a SQLite database and we've connected it to our app. This is the foundation. Our data layer is now ready to go. In the next module, we will build out the CLI functionality to actually use this data. All right. So thank you for watching. I'll see you in the next module.